Okay, this is a video that's going to show you how to make a graph of your penny density data that was collected in the lab. And the first thing that we need to do, because we're going to be using Google Sheets, is to open Google Sheets. So on the computer, if you click on the Apps button here and you go to Google Sheets, it will open Google Sheets up. And what you want to do is choose a blank Google Sheet. My web performance at home is a little bit slow, which is where I'm making this video, so I apologize if there are any glitches or waiting that has to be taking place. So what we want to do is we want to name it, and what I would like you to do is put your last name, and if there's more than one of you, you can put your last names. I'm going to call it Binky Penny Density Data. And from here, we are going to create our columns, and we want to write last names in the first column, balance number in the second, mass, and I'm going to put a little g in parentheses, which stands for grams, in column C, initial volume in milliliters in column D, and final volume in milliliters in column C. Now you can see that a couple of things here. There's some overlap here. So one of the things that we want to do is we want to set up this row so that the information doesn't carry over like this. So what you have to do is click on row 1. It'll highlight that whole row, and you go to Format, Text Wrapping, and instead of Overflow, we want to choose Wrap. So what that does is it allows all of the contents of that cell to be seen. The next thing before we start adding data that you want to do is highlight everything in this column, and I think it looks nice if you bold it. And as you're putting data in and you scroll, we want this row to be stuck in place so that as you're scrolling down, it can be seen. So we want this frozen in place. And the way that we freeze that in place is you can go to Format. It might not be Format. View. Freeze. And we're going to say that we want to freeze one row. Alright, so now you'll notice that if I have information here and I scroll, that is frozen in place. So that is handy, especially when you're putting data in. Alright, so I'm going to just fill in the first sheet here, Benke, B-E-H-N-K-E. If you have a partner, you would put your partner's names here. You only need one of you to do this per group, so you can both work on the computer at the same time. I had balance number 32. My first mass was 35.71 grams. Notice here, and this is very important, I did not put a little g after this. The content of these cells must only contain numbers. This little g here indicates that everything in this column corresponds to a measurement that has to do with mass, and the units are grams. My first initial volume was 10.5, and then my final volume was 14.0. And one thing that you'll notice, even though our graduated cylinders could measure out to the tenths place, which is why I included this in my measurement. As soon as I hit enter, by default it's going to get rid of that 0.0, and that's okay, that's just what happens. Alright, so I have all of my data copied already from a previous, I guess maybe I don't. Here it is. So I'm just going to copy my data. At this point you would be putting all of your data in, and here I'm just going to paste, and there is all of my data. I do not know what that is. I'm going to clear it. I'm just going to delete that row. Okay, so this is all of my data. I'm going to just tidy this up a little bit by making the rows a little bit more narrow as I can, so that I can have all of the data there at the same time and close together. Alright, so the goal of this lab is to calculate penny density, and in order to do that we need two things. We need the mass and we need the volume. And to get the volume in this lab we used water displacement, in which we put a stack of pennies into a graduated cylinder in which the very first volume measurement was read, and then we measured the final volume. Right here I'm going to show you how to do a calculation. And to do a calculation always starts with an equal sign. And I want to take my final volume, which is in cell E2, and subtract my initial volume, which is in cell D2. So I'm going to type in E2 minus D2, and I hit enter. And that is my penny volume in milliliters. And one thing that is super cool about this is I only need to do this once. So if I click on this cell and I hover over this little blue square, I can click holding the mouse down and drag to the bottom, and all of those measurements were just made for me. Okay. Now, one thing that we can do right now is we could calculate the density for each one of these measurements. But that is not really the point of this activity. The point of this activity, as should have already been discussed in class, is to show you that if we plot a line of mass versus volume for a series of data collected, the slope of that line is equivalent to the density of the substance. It's an experimental density. And the goal is to see how close we can get. So I'm going to show you how to make that graph. What we need to do is, if we want the penny volume on the x-axis, it has to be in the first column. So what's best to do is these columns need to be side by side. So I'm going to highlight this mass column, and you can either hit Control C or copy, and then click on that column and hit paste. And this will allow, when you have two columns next to one another, the first column is going to be what gets put on your x-axis, the second column will be what gets put on your y-axis. So I'm going to highlight this data, and I'm going to insert a chart, and I would like it to be a scatter plot. And here we have the chart. I'm going to make the screen a little bit smaller so that we can see it all at once. Alright, so here is the chart, and one thing that I noticed right away is that there is a point here that is really not, it doesn't belong. It is clearly an outlier. Something went wrong with this measurement. You can see this nice trend, but this one is clearly an outlier. So I'm going to remove it from the data set. I'm making that decision because I have all of these other measurements and this is very clearly out of the way. So it looks like it is the one with a mass of 142 grams. So I'm literally just going to remove it from the data set completely. Okay. So the next thing we want to do is insert, just giving this a little bit more room, insert a trend line. So to do this, we have edit chart, and under customize, we choose the series and we choose trend line, and we want it to be a linear trend line. Another thing that we want to do is we want to have this indicate what the slope of this line is, because remember, when we collect a set of data with an element or any other substance in which we have many collected points of data for mass and volume, the slope of that line is going to be equivalent to an experimental density. So I want to show the slope. If we choose label, we can choose equation, and the slope is right here. It is the y equals mx plus b slope, and the y equals mx plus b equation, and in this is the m that is equivalent to the slope. So according to my data, the density of the pennies experimentally determined is 7.38 grams per milliliter. So let's see how this compares to what the accepted value is for pennies. This is a website that talks about the density of the US penny. It talks about how in 1982 the mint decided that the cost of copper was too expensive, and they switched over to making a penny that was mostly zinc. So the accepted value of this is 7.2 grams per milliliter. If we would have used the older pennies, the accepted value for that was 8.8. So, but we didn't. We used the newer ones. So the accepted density of the newer copper pennies is 7.2. So let's go ahead and look back at my graph again. This is my data. I got 7.38 as my experimental density. And in class or in a future video, I'm going to show you how to calculate a percent error. But I feel pretty good about this. At least I didn't get 9 or 6. So I feel like I'm in the ballpark. So I would like you to make axes labels. This is a graph of mass versus volume. Whatever is on your y-axis is what you start with, mass versus volume. So I'm going to say mass. I'm going to call it penny density. Mass in grams versus, you probably hear my dog barking in the background. He wants my attention, but he can't have it right now because I'm finishing this. Volume in milliliters. So we will call it penny density graph, and it is mass versus volume and slope intercept slope data. This gives us a sense of what the graph is showing. Now we also want to insert some titles for the other axes. And where is it? Chart title, horizontal axis title, I am going to type right here, penny volume in milliliters. And if I hit enter, it shows up. I do not think this is very easy to read. I think that the text should be made bigger. Yeah, that's a little bit better. Maybe I'll go to 18. And then I'm going to put the vertical axis title in. And I'm going to say penny mass in grams. And again, I'm going to choose this to be a larger font. It looks like I forgot there. And the title, I think, could also be made a little bit bigger or maybe smaller. Maybe I want to center it. I think that that looks a little bit better. And there I have a title. The graph uses up most of the space. Now, one of the things is there's a lot of empty space here. And if I want my line to fill up the most space, I probably could get rid of this. So if I click on this axis, I can choose I have to see a minimum value of 25. And what that does is it just kind of uses the whole area a little bit better so that this whole area is filled. Another thing that I think I would like to do is have on this axis my numbers, the grid lines, be in increments of 1. So I clicked on this horizontal axis and I will see how, maybe I can't, a scale factor. I'm not really sure how at this point. So that's not really the point of this. If you can discover how to change that, that would be great. So I have to finish up this right now. I would like you to print off your graph, show it to me first, and then print it off. And then I'm going to follow up with some further instruction or maybe another video.